Hello and welcome back to the course on deep learning. In today's tutorial, we're going to walk through the steps that are included in the process of training an autoencoder. So let's get started. Here we've got an autoencoder, and obviously it gets some inputs and then it'll get some outputs. And in our case, it'll get inputs, you'll get the ratings of lots and lots of users for these 6 movies. And based on those ratings, it'll come up with a way to compress that information and come up with those weights that will allow it to encode or to basically set itself up to be able to then encode it and decode it in the future. So here we go. These are our training steps. Step 1, we need to start with an array where the lines correspond to users and columns correspond to features, the movies, and each cell contains a rating from 1 to 5, 0 if there's no rating. By that user use. So important to understand that every single row in your data set is a unique user who rated those movies. And by the way, these steps will be very valuable for you when you are performing when you're doing the practical tutorials, because you will be actually working with exactly this situation. You'll be creating a recommender system for movies. Step 2, the first user goes into the network. The input vector contains all its ratings for all the movies. So all the ratings of that user for all of the movies. Step 3, the input vector is encoded into vector z of lower dimensions by a mapping function. Usually you'd use a sigmoid or a hyperbolic tangent, as we mentioned. And that's the equation that you would have. Then step 4, z is then decoded into the output vector of the same dimension as x, aiming to replicate the input vector. So this is all pretty straightforward stuff. The reconstruction error, which is how different is the output compared to the input, is computed, and the goal is to minimize your reconstruction error. And then all this error is backpropagated from right to left through your network, and the weights are updated accordingly, depending on how much they're responsible for that. So you've got a gradient descent process happening there. And the learning rate describes how much we update the weights. That's a parameter you can tune during you will be tuning during, or you can tune during the coding, and you will see that in the practical tutorials. And step 7, repeat steps 1 to 6 and update weights after each observation. That's reinforcement learning if it's done after each observation, or if you do it after batches, that'll be batch learning. And finally, step 8, when the whole training passes through the neural network, that's an epoch, and then just redo more epochs. So there we go. Those are our steps. Let's have a look in a more visual way. So step 1, that's our input. In this case, this input is the same file as we used for the Boltzmann machine, or same example. You can have ratings from 1 to 5, as we mentioned in the example. 1 to 5 means basically a more advanced recommender system, and then a 0 would mean empty. In our case, we got 1, 0, and empty. We can easily change them. We can change these 1, -1 and put a 0 in the empty cell. So it's very easy to adjust. And also you can build a recommender system with ratings, with binary ratings, 1 and 0, or 1 -1, depending on how you want to structure it. It'll be a good recommender system. But of course, it'll be a more powerful recommender system if you build it with ratings from 1 to 5. And in the practical tutorials, good news, you'll be building one with ratings from 1 to 5. Okay, so there we go. That's our input. Then step 2, we take the first row, we put it into our autoencoder, and then step 3, we calculate the hidden nodes. Voila. And again, at the very start, you'll have some randomly initialized weights. Then that process is called encoding. Step 4, we're going to calculate our visible output nodes. Again, initially it'll be some random starting weights. And that's a process called decoding. And then, so basically, this is a summary. That yellow arrow is a summary. We've just put the information, the data through our autoencoder from left to right. And step 5, we're going to compare the results to the actual ratings for those movies. Movie 1, 2, 3, 4, 5, 6. And then we'll calculate the error, step 6. And then we will propagate it back through the network. We will adjust the weights accordingly. And next, we will take the next row in our data set, and we'll do the same thing, and so on and so on and so on. We'll continue through all the rows. And then once we're done, we move on to step 8. That means we've finished a whole epoch, and then we just repeat these epochs. We continue doing that with our data set, depending on how many times we want to do that, and hopefully our training converges to some sort of value. There we go. That's how you train an autoencoder. Very straightforward steps. And as I mentioned at the start of this section, that simply because you've already done all of the previous parts of this course. All of this probably sounds very trivial to you. If you look back at how you were starting out into this course, this probably would have been a bit more advanced. But if this sounds trivial, that's good news. That just means that all of the knowledge that you've acquired throughout the course before is benefiting you now. And that's great. That's why we were able to fly through this part very quickly. And we can move on to some more interesting things. And by the way, additional reading, we've got some additional reading today. Here is a blog by Francois Chollet, the creator of Keras. It's called Building Autoencoders in Keras. Check it out. It's got some actual practical applications. So even if you want to get some hands-on experience before you start the practical tutorials with Heidelberg, this could be a good place to do that. There's some quick exercises which you can follow and get some cool insights already, and then you'll be even more prepared when you go into the practical tutorials. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.